Ever opened your textbook, stayed at a page for 10 minutes, and still had no clue what it said? Yeah, me too. Or started watching a course online and then boom, somehow ended up watching cat videos? Been there, done that. The truth is, traditional learning isn't built for our generation. We've grown up on YouTube, Instagram, and personalized feeds that get us. But when it comes to learning, we're still stuck with old school methods. Long chapters, zero engagement, no flexibility. We want to learn, but the system is literally pushing us away. That's where BookTube comes in. Imagine if your textbook was turned into a personalized, bite sized content stream like Coursera plus YouTube, with all your topics broken down into simple and engaging reads. No fluff, no boring pages, just pure, customized learning. Got a textbook? BookTube turns it into bite sized, fun articles made just for you, like bullet points or even real world examples. Pick your learning style and we deliver. Whether you are starting out or already a pro, BookTube tailors every topic to match your level. Found something that clicks? Hit bookmark and come anytime later. Too busy now? Save it to read later. Want to group your favorite topics? Create your own playlist. And yes, you can download any article as a PDF to study offline. It's your own study space, your pace, your way. And get this, it recommends what to learn next based on your interests, like Netflix, but for your brain. BookTube isn't just another learning app, it's your personal learning assistant, built the way your brain actually wants to learn. It's modern, beautiful, and smart, and most importantly, it actually makes you want to come back and learn more. So, if you are ever left behind by boring books or confusing courses, BookTube is for you. Let's learn smarter, let's learn your way.
Hello and greetings. I am Jay Mangukia, currently studying in semester 6. As a part of AI project, I implemented content-based recommendation system in our already ongoing HCD project. So our HCD project was based on BookTube, which is a generative AI-based web application which converts your textbooks and syllabus into consumable course content, which contains topic-wise articles. So I would like to explain about the recommendation system which I applied in brief. So the reason why we implemented content based is that each and every users are having their own unique articles and the whole course. So based on their preferences such as learning style, reading style, their skill level and all those things. So it was not that feasible to recommend other users content to other users because everyone is having their own unique content. So that's why we opted content based recommendation, which I applied on homepage as well as article page. So I would like to provide a very brief go through to the code. And before writing the most optimal and efficient code, I went through several iterations, which one of them is this code. This recommendation is based on very basic TF-IDF, so it wasn't providing that efficient result. So we canceled it and implemented some other sentence transformer based approach. And for that, we have used the all mini LM L6 sentence transformer, which is proven to be very efficient and better than TF-IDF. So for that, what we did is the article we took, let me show this one. Okay. So here comes the data part. The data is being passed in the data frame format, which contains ID and description. So the ID is nothing but the each article's own unique ID, and the description is the content of that article. So now every articles are going to be long, so that needed to be summarized. So for that we implemented vectorization using the sentence transformer model. And as you can see over here, this is one of the example of that article content. So this was one of the iteration which proved to be not that good. So this is the final one. As we can see over here, this is the data frame format which contains the IDs and the article content. And based on that results, we are calculating the cosine similarity and all those things, and at last we are getting the results. Now, the final code which we implemented is this. As you can see over here, just a minute, yeah. This is the recommendation service used for article page. What it does is that whichever article is opened, it is going to recommend three articles based on whatever article is open. Suppose if computer network related article is open, then it is going to recommend three articles related to that computer networks field. So this is about the article page code. Now this recommendation algorithm, this function accepts three parameters, which is data, article ID, and top K. Now the data which I told already is the data frame which contains ID and description, which is the article content in pair form. This top K is, as I told, the top three articles will get recommended, and this article ID is that article which is currently open. So the article which are recommended which will be with respect to this article. So yeah, the simple logger functionalities, then try and catch methods, and here is the model. Now there is another twist that this model is efficient, but it is time consuming, so it takes a lot of time. So we implemented our own installed model, so which takes little bit lesser time than the original one. So yeah, that is the change in our code. And yeah, this is the simple functionalities which I explained, embeddings and cosine similarity calculation and all those stuff. Now here is the go through about recommendation controller. From, as you can see over here, this line, this is the line which provides the, which calls the recommendation algorithm function, and which passes all the necessary parameters as seen over here. Now talking about the home page, which you can see over here, just a minute. Yeah, this home page, these all articles which we can see over here are all the result of recommendation, content-based recommendation. So how we did this, I'm going to explain. So as you can see over here, there are playlists, there are history, the read later, which is completely based on user's activity. So we are randomly picking the some of the history based article, some of the playlist based article, and some of the read later based article, and as well as the bookmarked article. So what will happen that some of random articles will be collected from over here, and if I show this one, yeah, as we can see over here, user history, read later, bookmark, and the data will be gathered, and based on this one, based on the cleaning and filtering and all those things, we are going to recommend articles based on the user activity. So this is how it works. The recommendation algorithm will be mostly the same. The parameters and the model and all the internal process will be going to the same. So yeah, this was about homepage and article page recommendation. As we can see over here, it is going to recommend only 20 articles, which is set by us and based on the user activity. So yeah, this was from my side, which the recommendation system which I implemented, and the further will be explained by some of my peers. Thank you and have a nice day.